That means when you configure them 1s2, 2s2, 2p6 and the likes, they are going to end on p orbitals. And then we said that this group of people are found in the group 3 to group 13 to 18 of the periodic table. Their location in the periodic table is 13 to 18. Why is it 13 to 18? When in our O-level knowledge we believe that there are 8 groups. So how come does the group in the periodic table become 18? Listen, whenever we count the group of the periodic table, we usually omit a 10 bridge, 10 columns of bridge, and they are called the transition metals. So if this is group 1 and group 2, and you count these 10 rows of the transition metals with them, that means your former group 3 become group 13, then 4 become 14, 5 become 15, 6 becomes 16, 7 becomes 17, and 8 become 18. So you cannot find them here or within the transition metals. They started from group 13, 14, 15, 16, 17, 18. So they are located from group 13 to 18. Alright, if you do not understand what I mean by p block element and why I said they are elements that are actually partially or they fully filled the p orbital, they actually touch the p orbital. That's what we meant. So now this is the periodic table, as you can see. So let's take an example in each groups and let's configure them and let's see what will happen. But I'm not going to configure the transition metals, but I'm going to use the period 2, like this row. But don't forget that I said all these people from this side to this side, they are p block elements. Why this are not p block elements, including this. These are group 1 and group 2, they are not p block elements, and these are transition metals, they are not p block elements. So let's take lithium for instance. Lithium is 3 atomic number, so it's going to be 1s2, 2s1. If we take beryllium is going to be 1s2, 2s2. But if you take boron is going to be, this is 4 atomic number, boron is going to be 5, and it's going to be 1s2, 2s2, 2p1. What do you notice in boron? Boron who is here? Why? Lithium and beryllium that belong to this group, they did not enter the p block. But when I configure boron, which is here, which I've already established that p block elements are found in group 13 to 18. So this boron now actually shows that boron has at least 1 electron in the p orbital. That means boron is a p block element. Are we together? Now let's take carbon. Carbon is 6. Carbon is 1s2, 2s2, 2p2. So carbon 2 also has about 2 electrons in the p orbital. So that's why they are p block elements. P block elements are elements. So if I configure for all these ones too, nitrogen, oxygen, fluorine, neon, aluminum, silicon, phosphorus, sulfur, chlorine, argon, gallium, germanium, astatine, selenium, iodine, krypton, indium, tin, and lead, tellurium, antimony, tellurium, astatine, xenon, then titanium, lead, bismuth, polonium, and all of them, they are going to enter the p block orbital. They are going to enter the p block orbitals. And as I said, these people at this side, group 13 to 18, are p block elements. So hope you now understand why we call them p block elements. They are elements that when we configure them, it shows that they have electrons in the p orbital. Thank you. Trying to explain to you the location of the p block elements. And I said earlier that p block elements are elements that are actually, when we configure them, they actually have 1 or more electrons in the p orbital. And according to this structure, this is the periodic table, and these are the group 1 and group 2. But normally we don't use to count this gap, which is 10 columns, which are transition metals, together with the groupings in our O-level knowledge, under-level knowledge. But now we have to count them. So if you count group 1, group 2, and you count the 10 gaps of the transition metals to it, that means the last person here will be the 12th, because this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So because they are 10 plus the 2 that you have before, that's 12. So your former group 3 become group 13, group 4 become 14, because you have actually counted the 10 rows of transition metals, 10 columns of transition metals. So group 5 become 15, 6 becomes 16, 7 becomes 17, and 8 become 18 respectively. Now what we're now saying is that the p block elements are found here from group 3 to 8 or from group 13 to 18. If you are talking based on under level or O level knowledge, they are located in group 3 to 8. But in advanced level, which is now because we are now in 200 level, is from group 13 to 18, because we have actually counted the transition methods to with them. Alright, now the next thing we are going to learn in this video is what is the outer electronic configuration of the p block element. Now when you are asked this question, we know that the p block element that we want to study, that we usually study in the university degree, as an undergraduate, is the p block element that is above cation. When we omit this transition methods, the p block element that is above cation, and then since we said p block elements start from here, that means we are talking from gallium. So if you configure these guys, since S block always precedes a p block, everybody here, they are called p block elements. Before you get to the p block, because they partially fit the p block, they touch the p block, you have to first configure an S block. So that's why the general formula for all of them, since they are found in just 6 group, 13 to 18. If you count from 13 to 18, that's 6 group. So this is their configuration. You will first fill a s orbital fully before filling it. That's why the general outer configuration for all of them is ns to np 1 to 6. That 1 to 6 is telling you the range. That means group 13 we have ns to np1 as their own outer electronic configuration. 14 ns to np2. Group 15 ns to np3. Group 16 ns to np4. Group 17 ns to np5. Group 18 ns to np6, which is the extreme. That's why we generalize it. They are the outer electronic configuration of all p block elements is ns to np1 to 6. So if you are in group 13, you will have 1 on your p orbital. If you are in group 14, you will have 2 on the p orbital. So this n can be any number, because we have energy level. There are some that can be 2p, that can be 3p, that can be 4p. So we don't know the number, but we shall know that any p block element must already have a s orbital that will precede it before the p orbital. But in order of hierarchy, 13 we have 1 on the p orbital, 14 we have 2, 15 we have 3, group 16 we have 4, group 17 we have 5, and the last group, which is the group 18, we have 6. So the outer electronic of all the p block elements is ns to np1 to 6. But since we are treating group 13 to 16 in this course, KV212, then we are only going to streamline our knowledge to this space and this space. Therefore, stop here. The outer electronic configuration group 13 to 16 is nh to np1 to 4. If you are talking about group 13 to 16, it is ns to 1 to 4, ns to np1 to 4. But if it is for all the group p block elements from 13 to 18, then it's going to work with this ns to np1 to 6. I hope you will learn something. Please press the subscribe button to subscribe to my channel, and please share, recommend for people. This is Igwe Abdus. We love you. Bye.